Good morning, everyone. Greetings to all. Myself, S. Vimal Justin, lecturer of Emmanuel Research College of Pharmacy. Today, we are going to discuss about an interesting topic called stereochemistry from Organic Chemistry Part 3. Let's discuss about it briefly. First of all, what is the definition of stereochemistry? Stereochemistry is nothing but it is the branch of chemistry which deals with three-dimensional structure of molecules and their effect on physical and chemical properties is known as stereochemistry. Before getting into the in-depth investigation about stereochemistry, I'm going to shortly explain about what is isomerism. Isomerism is nothing but compounds having same molecular formula but differ in their arrangements. Next one, stereoisomerism. Stereoisomerism is a part of the classification of isomerism. These stereoisomers are classified into two types. One is conformational isomers and another one is configurational isomers. And this configurational isomers is divided into two types. First one is geometrical isomers, another one is optical isomers. Next one is optical activity. Optical activity is passing a plane polarized light through the polarizing nickel prism. When passing the light through the nickel prism, such light's vibration occur in only one plane is called plane polarized light. The compounds which rotate the plane of polarized light are called optically active compounds, and this property is known as optical activity. Rotation of plane polarized light can be of two types. First one is dextrorotatory, another one is levorotatory. Dextrorotatory means if the compound rotates the plane of polarized light to the right side, which means clockwise, it is said to be dextrorotatory and it is denoted by the symbol plus. While another one is levorotatory. Levorotatory means the compound rotates the plane of polarization to the left side, which means counterclockwise. It is said to be levorotatory and it is denoted by the symbol minus. Next, I would like to shortly explain about chirality and achirality. The word chiral means hand. It is used for those objects which have right-handed and left-handed forms. That is, molecules which have handedness and the general property of handedness is termed chirality. Simply, chirality means an object is not superimposable upon its mirror image is called chirality. While achirality means object and molecules which are superimposable on their mirror images is called achirality. Next, let's get into the main subject, stereoisomerism. The definition of stereoisomers is isomers having the same molecular formula but different spatial arrangement of their atoms are known as stereoisomers. They are of following types. One is enantiomers. Stereoisomers which are non-superimposable mirror images of each other are called enantiomers. Chirality is necessary and sufficient condition for existence of enantiomers. They always exist as discrete pairs. Next, simply diastereomers means stereoisomers that are not mirror images of each other are called diastereomers. Next, mesocompounds. Mesocompound is a compound that has more than one asymmetric carbon and that is superimposable on its mirror image is called mesocompound, and mostly these mesocompounds are optically inactive. Next, geometrical isomerism. This geometrical isomers occurs as a result of restricted rotation about the carbon-carbon bond. This is otherwise known as cis-trans isomerism. This isomerism exhibited by variety of compounds such as compound containing double bond, carbon-carbon double bond, carbon-nitrogen double bond, and nitrogen-to-nitrogen double bond. Next, conformational isomers. Conformational isomers are the isomers that can be converted into one another by rotation around a single bond. Example, eclipsed, gauge, and the antibutane are all conformational isomers of one another. These molecules can be interconverted by rotating around the central carbon-to-carbon single bond. A solid wedge line which represents bond projection towards the observer or above the plane of paper. A continuous line or ordinary line, it represents the bond in the plane of paper. A wedged line, it represents bond projection away from the observer or below the plane of paper. Example, methane. Next heading is plane of symmetry. The plane which divides a molecule into two equal halves which are related as object and mirror images is known as plane of symmetry. The molecules having plane of symmetry are achiral, which means optically inactive compounds. Next topic is DL system of nomenclature. This nomenclature is mainly used in sugar chemistry or optically active polyhydrocarbonyl compounds. This is a relative nomenclature because all the configurations described with respect to glyceraldehydes. All sugars whose Fischer projection formula shows the OH group on the right hand side of the chiral atom belongs to the D series. Similarly, if OH is on the left hand side, then the sugar belongs to the L series, which means levo-rotatory. D series means dextro-rotatory. Next, erythro and trio system of nomenclature. This nomenclature is mainly used only in those compounds which have only two chiral carbons and the following structures. When two like groups in Fischer projection formula are drawn on the same side of vertical line, the isomer is called erythroform. If these are placed on the opposite sides, the isomer is said to be trioform. These are the examples of trio and erythroform. Note this. Next, we are going to study about R and S nomenclature. Previously, we have discussed about D and L nomenclature. D means dextro, L means levo. Now, we are going to discuss about R and S nomenclature. The order of rearrangement of four groups around a chiral carbon is called the absolute configuration around that atom. The R and S nomenclature involves two steps. First step, the four ligand atoms or groups attached to the chiral center are assigned a sequence of priority according to sequence rules. Rule number 1. If all the four atoms directly attached to the chiral carbon are different priority depends on their atomic number. The atom having highest atomic number gets the highest priority. The atoms with the lowest atomic number is given to lowest priority. The group with the next higher atomic number is given to the next priority, and so on. Rule number 2. If two or more than two isotopes of the same element are present, the isotope of higher mass receives the highest priority. Rule number 3. If two or more of the atoms directly bonded to the chiral carbon are identical, the atomic number of the next atom is used for priority assignment. If these atoms also have identical atoms attached to them, priority is determined at the first point of difference along the chain. The atom that is attached to it an atom of higher priority gets the higher priority. Rule number 4. If a double or a triple bond is linked to chiral center, the involved electrons are duplicated or triplicated respectively. By studying this rule, we obtain the following priority sequences, which means increasing priority. Thank you for watching this video. I hope this chapter stereoisomers was very clear to everyone. Stay connected with us to get an in-depth investigation and discussions about the organic chemistry.